Alright, so this video focuses on the hyperbola or the reciprocal function at the grade 10 level. Now, let's start off with the mother graph. So, as mentioned before, the mother graph is basically a standard graph that no adjustments have been made to, no shifts have been done, no reflections, no translations, no nothing. So the standard graph for a hyperbola is y is equal to 1 over x. This is the mother graph, sorry, the mother graph. Now, how do you know it's a hyperbola? It's because your x value here is on the denominator. So when you have x as a denominator, then the graph you're looking at or talking about is a hyperbola. One thing to note about this function, this graph has two pieces that are not connected. So a hyperbola always exists as two pieces. Here's one piece over here and one piece over here. Now they always exist separately from each other, meaning opposites in opposite directions. So if one is here, one is here, or if one is there, the other one is there. It's that sort of concept, right? So it always exists as two parts, but it's on the same graph. If you have a point here and a point here, it counts as being on the same graph because they're both on the hyperbola. The form you're gonna need to know for test purposes and sketching and finding equations is this here, something we call the standard form. Now, we're gonna talk about this in a second, but let's introduce a couple of concepts with the hyperbola. Firstly, the hyperbola introduces a word called an asymptote. An asymptote is a line that a graph gets infinitely close to but never touches. So what does that mean exactly? So if you have a look here, you see that I've drawn this hyperbola and it's getting close to this x-axis. So here's our x-axis traveling over here, and here's a hyperbola. Now what happens is this hyperbola gets closer and closer and closer to the x-axis, but it never touches, never ever touches. Even if you go right up until infinity, it will never touch the x-axis, but it will always be getting closer to the x-axis. Now how does that work? Suppose the distance from here to here is 1 unit. The distance from here to here could have been half a unit. This could have been a quarter of a unit. This could have been an eighth of a unit. So let's say if you started off here, this could have been 1, then you have 0 0.5, then 0 0.25, then 0 0.125, then 0 0.01, then 0 0.00001, 0 0.00, and then you get this tiny number, meaning that line is so close to the axis, but it still never touches. There's still an infinitely small number between that graph, or a distance between that graph and the x-axis. So that is the concept of an asymptote. Now this graph has two asymptotes. So your straight line didn't have an asymptote, your parabola didn't have an asymptote, but your hyperbola has two. So from my explanation now, you should have been able to see one of those asymptotes. So the one asymptote actually lies right on the x-axis, right on top of it. Alright, so we call this asymptote, the one that runs from left to right, the horizontal asymptote, because it's practically a horizontal line. But what is the equation of this asymptote? The equation of this asymptote is gonna be y is equal to q. Alright, so I did make a mistake here. This goes over there and this goes over there. So your horizontal asymptote, this one here, is going to be given by the equation y is equal to q. the value of q comes straight from there. So if you know the value of q, you know the horizontal asymptote. The other asymptote we have is the vertical asymptote, which lies straight here down the y-axis. It's vertical because this is a vertical line, and its equation for grade 10 purposes is x is equal to 0. This graph gets infinitely close to the y-axis here and the x-axis there. This one gets infinitely close to the y-axis here and to the x-axis there. So if they ask you for the horizontal asymptote, this is your answer. You just submit this in with your q value, and for the vertical asymptote, this is your answer. The next thing that the hyperbola has is something called an axis of symmetry, similar to how we had one for the parabola, but it has two. So can you imagine how you would cut this graph? So remember these two pieces, where you would put a cut so these two halves fit onto each other perfectly. So the first cut is if you had to cut down this way. So if you cut a diagonal this way, then this half would fall onto that half. This is a mirror of this, and this is a mirror of this. So this line is the first axis of symmetry. Now, one thing about this axis of symmetry is it's going up as you go from left to right, so it has a positive gradient. So this is called the positive axis of symmetry and is given by the equation y is equal to x plus q. Again, q comes straight from there. The other way you can cut this graph to make it identical or to get an axis of symmetry is this way right here, where this folds onto this. So this half would be a mirror of that half, and that line from left to right is going downwards, so it has a negative gradient. So it's the negative axis of symmetry, and it's given by y is equal to minus x plus q. So the positive axis of symmetry has a positive 1 gradient, and this has a negative 1 gradient. So that has to do with your axis of symmetry. If they ask you for your positive axis of symmetry, it's this, and if they ask for negative, it's this. The next thing we now need to know is, because there's an asymptote, a point where this graph never touches, your domain and range have a simple complication. They have a simple adjustment. The idea is that your graph, if you go infinitely towards the positive x-axis, it exists, and even negatively, so this graph will continue there and this graph will continue here. So we would say x is an element of real numbers, but there is an x coordinate right here that the graph is not allowed to touch. Remember, it gets close to it, but it never touches an x coordinate of 0. So we say that it doesn't touch x is equal to 0. So x is not equal to 0. And similarly for your y, your range, it goes infinitely up and infinitely down, but it never touches this y value here of y is equal to 0. But I'm writing y is equal to q because this graph can move up or it can move down, and q is also known as the vertical shift, so it will tell you how far up or down you are moving. So this is our vertical shift. It tells you how far up you are moving, and the equation of that asymptote, remember the horizontal one is y is equal to q. This line here moves based on this. So if you have a +1 here, your asymptote is at +1, and we say y is equal to +1. Or if it's a -4, then this thing here goes down 4 units, and then we say y is equal to -4 as our asymptote. Alright, so it depends on that. So our range also means the asymptote is going to move when you move q, which thereby moves the y value that this graph doesn't exist for. Right. The next thing we need to know is, from our standard form, the letters a and q. So q if it's greater than 0 means the graph is moving up, which I just explained to you now. So if q is plus 3, the graph moves up 3 units. Or if it's negative 3, the graph moves down 3 units. Now the value for a, if the value for a is greater than 0, or if it's a positive value, the graph exists in this setup. All right, so in that sort of style, one in the first quadrant and one in the third quadrant. But if it's less than 0, or if it's a negative value, then your graph exists in the second and fourth quadrant. All right, bear in mind that these lines that you're seeing here are the asymptotes, not the axes. It's the asymptotes. All right, so you just make that slight distinction for now. Though the only time you'll really see it play in is mostly next year, but those are the asymptotes. So remember, it'll exist above and before your asymptote here, and after and below your asymptote here.